Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to the first lesson in our fourth unit. This unit will focus on chemical kinetics. Today, we will begin by learning what reaction rate is. We will also discuss a basic formula for looking at the relationship between the reactants and the product during a chemical reaction. In the following lessons, we will learn how to determine reaction rate and learn what factors affect it. Let us get started. Chemical kinetics is an area of chemistry that focuses on rates and reaction mechanism. Reaction rates are concerned with the rates or speeds at which a chemical reaction takes place. Some chemical reactions occur within seconds, while others can take days, months, or even years to complete. Let us get started with an activity. Students, please think of two chemical reactions that take place during a small amount of time. Then, think of two chemical reactions that take place over a longer period of time.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. What chemical reactions did you think of that happen in a short amount of time? You might have said the combustion of gasoline or the explosion of gunpowder. Both are correct and occur within only a few seconds. What chemical reactions did you think of that happen during a longer amount of time? You might have said the weathering of stone or the breakdown of plastics. These two chemical reactions take years to complete. That is why the plastic that is sent to garbage dumps stays there for a very long time. The word kinetic refers to motion or action. So, chemical kinetics refers to the rate of action, or, in this case, the rate of reaction at which reactants change into products. Let us look at an example. When hydrogen is combined with iodine, hydrogen iodide is created. In this formula, the rate at which hydrogen iodide appears is known as the rate of reaction from left to right. The two reactants are shown on the left side of the equation, and the product is shown on the right side. The product in our example, or the hydrogen iodide, decomposes faster than the reactants, or the hydrogen and iodine, can produce hydrogen iodide. For the rate at which the hydrogen iodide disappears, because it is doing this faster than it can appear, we simply invert the formula. Thus, the rate at which hydrogen iodide disappears is known as the rate of reaction from right to left. The product is shown on the left side of the equation, and the reactants are shown on the right side. During a chemical reaction, the amount of reactants present decreases as the amount of product increases. This process is following the law of conservation of mass. As the reactants change, their particles change to become the product. The same particles are present, but in a new form. To calculate the rate of a reaction, you divide the change in the amount of reactants or products by the amount of time it takes for the reaction to occur. Students, let us do another activity. Using this formula, write the rate expressions in terms of disappearance of the reactants and appearance of the products.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. The correct answer will now appear on the screen so you can compare it to your own work. How did you do? Teacher, please go over this formula with the students at the end of the lesson. In this lesson, we learned the definition of chemical kinetics and how it applies to chemical reactions. We also learned a basic formula for looking at the relationship between the reactants and the product during a chemical reaction. Remember, students, the same amount of particles must be present on both the left and right side of the formula because matter can neither be created nor destroyed. This brings us to the end of our lesson today. Until next time, thank you, teacher. Thank you, students.